Hello, my name is Devin Wong, and today I will be presenting my project proposal for a bio-inspired robotic breastfeeding simulator for replicating infant oral motion and milk extraction. Some background on this project is that many mothers experience issues with breastfeeding that often leads to early breastfeeding cessation. These issues include mastitis, cracked nipples, and general breast pain. Many studies have been conducted on the benefits of breastfeeding and breast milk on infant development. However, the biomechanics side of breastfeeding has still remained unstudied and unknown. This project is an ongoing project led by Dr. Zhang. The bottom left part of the screen, a previous generation of the breastfeeding simulator is shown that features a breast model, head model, tongue actuator, and vacuum pump to simulate the infant oral pressures occurring in natural breastfeeding. On the right are results of infant oral pressures given a user-defined pressure. The objective of this project is to design and develop a high-fidelity robotic breastfeeding simulator for mimicking an infant's oral movement during the breastfeeding process for successful milk extraction. The main deliverables for this project will be the 3D CAD models for the upper and lower portion of the infant head model, a functioning prototype of the breastfeeding simulator, and plots of oral cavity pressures from the infant head model, vacuum pump, and tongue actuator. The evaluation metrics for this project will be breast milk extraction flow rate, breast milk total yield, imaging of nipple deformation, max numerical nipple deformation, and oral cavity pressure data. In order to achieve these deliverables, the current CAD model for the infant head model will be altered based off of infant CT scans. These parts will then later be assembled in SolidWorks before proceeding on with manufacturing and assembly to ensure fitment. Then integration between mechanical and electrical subsystems will take place, as well as implementation for a feedback control system for all the actuators, and a GUI will be made to take user-defined inputs. When the prototype is complete, the simulator will be run and sensor data will be collected and plotted as functions of time. This data will then be compared against clinical studies to measure the accuracy of the simulator. In order to complete this project, the main resources needed are an Arduino IDE, SolidWorks, 3D printing services, Arduino Mega 2650, a vacuum pump, linear actuator, 2 servo motors, and some piezoelectric pressure sensors. Some anticipated challenges for this project are on the manufacturing side. If there is any issue with the manufacturing service not being able to meet my timeline or have an issue with producing our CAD models in the correct material, in-house 3D printing will be used to produce the head model. The trade-off will be that the model will not be transparent and won't be able to be made of silicon. Another challenge would be that some of our components, if they break, may not be replaceable with the exact same components. So alternatives will have to be researched and the designs may have to be altered slightly based off of certain requirements. Some preliminary work that has already been completed is the circuit design and testing for actuators and sensors. This is work towards deliverable 2 of the functioning prototype. The actuators and sensors have been interfaced with the microcontroller as shown on the left, and the programming for the microcontroller was completed to test the actuators and sensors for functionality. The success of a high-fidelity breastfeeding simulator has great significance in helping doctors and lactation specialists better understand what the major causes of certain breastfeeding issues are. This can also allow them to provide solutions for mothers with breastfeeding issues more quickly.